Okay, this is a process control graph problem from the exceptional control flow exercise that we just posted earlier today, or actually last week. Anyway, here it is. We're looking at a program here that involves using the fork function that creates processes, and so first question is draw the process diagram to the right. Alright, so what we have is initially we have the single process going, and then we print letter A, and we flush that, which just simply means we're going to force the output to be displayed before doing the next thing. Then we do a fork, so in this case we'll create a child process, and by convention I keep the parent process on the bottom and the child on the top. You can do whatever you like, but that seems a little, for me that's a little easier, so I do that. And the next thing you do is if PID is equal to 0, this means that this code here is executed by the child process because of the return value of fork is 0 for the child, non-zero for the parent. So in this case the else part is all going to be done by the parent. Okay, so if you're the child, that's this leg up here, we're going to fork again. So in this case do it again, and then followed by the printing of the letter B, and both processes would print a B. And then if PID is equal to 0, we print a C. So in this case the child process from here would then print a C, and after that we fall out of the main because this whole block terminates down here. There's nothing after that. So both of these carry on in parallel. Meanwhile, the parent process is waiting for something. We have a wait. The wait function waits for the first terminating process in the parent's wait set, and the wait set consists of all of its child processes. So in this case there's only one child process. Notice that there are two processes here, but there's only one child process of this parent. When the wait occurs, it doesn't wait for grandchildren, if you will. It simply waits for child processes. The child of the child is not part of the parent's wait set. So what happens is, and I draw it this way, when this provides a synchronization point, the parent waits until the child process completes, and then it prints a D, and then we flush that, which means we print it out for sure. Then we fork again, and in this case if PID is not equal to 0, we'll print the letter E. So by convention, this is the parent, prints the letter E. This process just carries on until we reach the end of the function. So this would be the process control graph. Now what do we see from this? First of all, you notice that there has to be, before a D gets printed, there has to be at least one B. The B and the C and the B here can all be printed in any order. So A would always be printed first. We could have this B occurring, followed by this D, followed by this E, followed by BC. That would be okay. I could have B, BC, DE. But the constraints are I need at least one B, because this B has to be printed before this D, and this D has to be printed before this E. So any place that I've inverted any of these then is not a legal output. So first of all, we'll answer the questions. I've done the diagram. How many processes are created? Well, 1, 2, 3, 4. There's 4 processes that have been created as a result of this code. Circle the strings below that are possible. So A, B, B, C, D, E. Okay. Is that legal? Well, the A is okay. B, B, C, so B, B, C, D, E. Possible outputs. A, B, B, C, that could all happen. So there's at least one B before the D. There's a BC, that has to happen in that order. The C can't come before the B. It could come before this B. The so it well it could be BCB. That's possible. But in this case, so we're going to assume that that's possible. A, B, C, B, D, E. So A, B, C, B, D, E. That's a possible one because these can occur once again in any order. So that looks possible. And then A, C, B. Now in this case we have a C before a B. So if you'll notice that there has to be a B before a C. So this is not going to happen. A, B, B, C, E, D. Now notice that we have ED, and we see here that we have to have a D before an E. So that can't happen. A, B, D, E, once again. D, E is okay. B, C, what about that? Does that look like? So A, B, D, so that's okay. E, that's possible. And B, C, yeah, that's possible. So this one looks like that one could happen. So that sequence would be A, B, D, E, and then B, C happens. That's all possible because they're all concurrent. What about this one? A, D, E. Well, we know that because of this weight here that a B must come before a D, and that doesn't happen here, so that's illegal. So that's the answer. Write a program that uses execve to execute the ls system function. Your program should create a child process and use that process to initiate the ls command. So I'm just going to give you the outline. It's basically if fork something like this. There's more to this, but if fork equals 0, that's now, this code is now the child. Then you would call exec a flavor of the exec function, and if you chose execve, then you would give it the parameters. In this case, you would have an ls command and then a vector consisting of the ls command and then the environment. I'm not going to show all of that. There are other flavors than VE. Another common flavor would be exec. I believe it's LP. There's a couple of different versions of this that let you put the strings in directly rather than using an array of string pointers. So you'll need to work that one out yourself. I suggest that you program that and actually get it to work and make it happen. Write a short program that does it. These problems all have the answers in the back of the chapter, so check those out, and that'll just give you a little bit more practice.